Assalamualaikum. Today we are going to discuss about metallic bond. Metallic bond is the electrostatic forces that happens in metals, and it can be explained using electron C model. Okay, how does electron C model works? Okay, first of all, we have to remember that metal atoms are arranged in close packed and orderly array. That means all the metal atoms are very close to each other and they are in repeating order. And then the valence electron are delocalized throughout the entire solid, and the positive ions are immersed in the sea of delocalized valence electron. Okay, what does this all means? Okay, first of all, you have to remember the structure of an atom, where we have nucleus in the middle, and the nucleus is positively charged because it carries proton, and we have electron moving around the nucleus, and electron have negative charge. Okay, imagine this atom is inside a sample of metal, which is the atoms are very close to each other and they are arranged in repeating order. Okay, what happened is that since the atoms are very close to each other, the valence electron is not only attracted to its own nucleus but can also be attracted to the neighbor nucleus. This is because the nucleus are very close to each other. The nucleus are at close proximity. That means the distance between the valence electron with its own nucleus is almost the same as the distance with the neighboring nucleus. Therefore, the electron is not only attracted to its own nucleus but can also be attracted to the neighbor nucleus. So this will make the electron possible to move around not only in its cloud of orbital, but can also move around freely at its neighbor's orbital. So the illustration looks more or less like this. Okay, see the electron free moving not only to its own orbital but also around the neighboring orbital. This is because it is attracted to its own nucleus and the neighboring nucleus as well. So this attraction between delocalized electron and its own nucleus or the neighboring nucleus is what we call as metallic bond. So because of this, the electron will look like flowing water. Okay, flowing water, because it can move freely from one atom to other atom. So it is almost as looks like sea of delocalized electron, while the nucleus is acting like island, sitting or immersed in the sea of the delocalized electron. The strength of metallic bond increases as the number of electrons available for bonding increases. Because the number of electron to move around increase, there is more possibility for the electron to move around not only to its own orbital but also to the neighboring orbital. So because of a lot of movement is going around, therefore it will increase the strength of metallic bond. For example, we have sodium and magnesium, which is from the same period, which is period 3 but different group. Sodium is from group 1 while magnesium is from group 2. Therefore, sodium have only one valence electron and magnesium have more valence electron than sodium. So because magnesium have more electron to move around and to be attracted to the its own nucleus and its neighboring nucleus, therefore it will increase the strength of metallic bond in sodium. So in magnesium. So this is why boiling point of sodium is lower, which is 882.8 degree, while magnesium have higher boiling point, which is 1091 degree C, because it is more energy is required to overcome the stronger metallic bond in magnesium. Okay. The mobility of electrons also explain why metal can conduct heat and electricity. Okay, so the delocalization of electron also help for the heat or the electricity to be transferred from one atom to other atom. The illustration is more or less like this. Okay, let's say we have a source of heat on the right hand side of the sample. So what happened is the atom that is nearer to the source of heat will become hot first, and then it will transfer the heat to the neighbor molecule, and the third row molecule will the second row molecule will transfer the heat to the third row molecule. So this is possible because the electron is free moving, because the electron can carry the heat or the electricity supplied from the outside.